So today we will be talking about quantum mechanics. Quantum mechanics. And in that we will be talking about Schrödinger equation. So in Schrödinger equation, what is the Schrödinger equation? Schrödinger equation is an equation which combines the wave plus the particle nature of the particles at nano level or quantum level. Quantum level. And the main in this is the main symbols in Schrödinger equation is wave function and then we have this h bar. H bar is, we know what h bar is. H bar is Planck's constant, reduced Planck constant, reduced Planck's constant, and then we have this is psi. This one is time plus position dependent. So dependent mean evolution. It for this one, this psi x of t, x and t, the particles evolution, particle is observed both in time plus in motion or position. And then to make a Schrödinger equation, we mostly use H. It's the simplest way to make Schrödinger equation. P2 square m, 2m plus v of x and t. So here P is momentum operator, m is mass, and h is energy operator. V is potential. We're just using the simple Schrödinger equation, the one in its simplest. It's H equal k dot E plus P dot E. But since we are making Schrödinger equation, we have to use this. And for Schrödinger equation, this over here is constant. This is constant. This is potential. Potential energy is constant. This is. Then when we talk about the equation, we need two things. One, we need to know what is P, momentum. Here it's I of h bar minus I h bar and this symbol. And what is this symbol? Further in, when we talk about this symbol, this is d over dx in derivation form. Then what else? Then we have, yeah, and by integrating these with psi of x and t, psi of x and t, we get the Schrödinger equation. This plus this psi of x and the psi symbol, this is the density, probability density, to get the probability of the particle. And so this is so then when we apply minus I h bar and this symbol into the equation, h equal minus, sorry, this equation, h equal p of square 2m plus v of x and t. Then we get, and one more thing, here this h is Hamiltonian mechanics, Hamiltonian operator, and it acts as a energy operator here, energy operator, because here h equal e of x and t equal I h bar d over dt psi of x and t. And I again, here one more is I, and I is complex number. And what is this number? This -1. Why is it a complex? Why is this a complex number? Because why is it specified is that -1, you cannot take a square root of a negative, so it has a specific name, complex number. We will be using complex number, Planck's constant, momentum operator, Hamiltonian operator, the potential energy. Here it's a constant, so we will specify constant. Then further on, what else do we know about momentum equation? So it was actually made by Erwin Schrödinger. So this equation describes both the particle nature, that particles travel in terms of particles travel in terms of this photons, like photon travels in terms of particles, they're photons, and as well as they travel in terms of rays or waves. This is particle, this is waves, and the combination of these two give us is what the Schrödinger equation tells us. So Schrödinger equation is actually the combination or easier way of knowing about the system in quantum mechanics. So if we have, then what else we have dependent. So then particle nature, Hamiltonian. Here it's energy. E is energy. Energy. And then